Welcome, y'all. Back to some more geometry fun. Today we're talking about areas of similar figures. All right, so when we talked about before, when we're talking about similar parts, we're talking about perimeter and proportions and just comparing side to side. So we always had to find a scale factor. Scale factor, you remember, but just taking one, taking one part over part as some sort of either as a fraction or we did part to part like that. So for example, we take similar parts, 10 to 15. We say, hey, well, 10 to 15, it's a scale factor. We reduce that, we get 2 to 3. So our scale factor is 2 to 3. This is our A to B ratio, or an A to B, something like that. That's just the letters we're going to use, because when we talk about area, which is in a two-dimensional form, then we got to talk about area squared. So in normal scale factor with perimeter and just comparing parts, you're doing a one dimension, this to this. When we do areas, two dimensions, so we got to square our units to kind of fit that trend. Later in the next chapter, we'll talk about volume and we'll talk about three dimensions. So you're right, or guessed it, we're going to cube those. So it says right here, the scale factor two similar figures are just A to B. And the ratio of the perimeter is A to B. So the ratio of their area is A squared to B squared, also can be written as A squared over B squared. So let's take this as an example. Here we got 5 to 8, so that'll be our A to B will equal our 5 to 8. Now, we are missing one area, but we're looking for the other area. So we set this up as a proportion. We'll say, all right, so A squared to B squared, so 5 squared to 8 squared is equal to this area, the area of the smaller one, x over the area of the bigger one, 32. Now, if you were to write this the other way around, if you do 8 squared over 5 squared, then you will have to flip this. The way you set up this proportion is the same way you will set up the area ratio here. So we square these numbers, we get 25 over 64 equals x over 32. And then we cross multiply. So 64 times x gives us 64x. 25 times 32 gives us 800. We divide both sides by 64. That will give us the area of the smaller figure. X equals 12.5. And this is area, so it'll be units squared. All right. Let's look at another example here. All right, so here we first establish what is our scale factor. What is our scale factor? So let's find similar parts. Hey, we got this, Perfect. There, it looks similar. Angles kind of match up right there. Smaller angles right there. So that kind of tells us, all right, so then these two sides have to match up. So we'll go 6 to 8. So our scale factor is 68. Reduce it. You keep it at 6 to 8, but let's go ahead and reduce this, get smaller numbers. We get 3 to 4. So our scale factor is 3 to 4. All right, so since we're doing area, we'll do A squared to B squared equals our area of our smaller one over area of the bigger shape. So A squared being 3, so 3 squared over 4 squared equals the area of our smaller one, 13.5, over the area of a bigger one. That's our x this time. Square our numbers, we get 9 over 16 equals 13.5 over x. We cross multiply, we end up getting 9x equals 16 times 13.5, which gives us 212. We then divide both sides by 9. Divided by 9, divided by 9. The value of x will equal, let's see, divided by 9, 24. So our area of our bigger triangle is 24 units square. All right, let's do another easy example. Just try it out again. All right, so this time, the question is find the scale factor. So we have two problems. We have to find the scale factor and then find the value of x, x being one of the sides. Well, to find the scale factor, we have to find the sides. So we kind of said the same way. So right now, currently, our scale factor is x to 10. Now, it does tell us the area of the smaller one is 54 and the area of the bigger one's 150. So then we have, all right, so let's do our area scale factor. Area scale factor will be a squared, which would be x squared, over b squared, which would be 10 squared. That equals 54 over 150. So we simplify this, we get our x squared over 100 equals 54 over 150. We then cross multiply, we end up getting 150 x squared equals 5,400. Again, the rest just works like simple math. We try to isolate the variable, get x squared by itself, so we'll divide both sides by 150. Divide both sides by 150. We end up getting x squared equals 36. And again, we're looking for just the value of x, so we square root both sides. The value of x equals 6. So that means x equals 6. That's one of our answers. And again, we're looking for the scale factor, so we plug this back into that. We get 6 over 10 and reduce that. Divide those by 2. We get 3 over 5 is our scale factor. That's our other answer. All right. Last one right here. So we are talking about my birthday is coming up March 6th. If anybody's wondering, turning 60. Not really, but hey, let's just assume we are. So, hey, there's two pans that we have. We have two hexagons of pans. Why do I have hexagon two pans, cake pans? Because I just love shapes so much. And who wants just a basic rectangle or square or circle? Let's get a hexagonal cake. Why not? So we have one smaller one and then one bigger one. All right. That's our current situation. Now they tell us like, hey, the side of the larger one is 4.5. All right. Okay, and the area of the smaller one is 41.6. So we don't know this area right here, right, as of right now, area, and we don't know this side. The first question is, what's the side length of the smaller one? So we're looking for x. Well, if we set up what we have right now, we have small side x squared over 4.5 squared equals our small area, 41.6, over our big area, which we don't have. If we cross multiply that, we're just left with ax squared. That don't help us. So what we're going to have to find is the area. So now remember, this is a hexagon right here, a regular hexagon to be important. And what's great about hexagon is that when you break this down, get the central angle is 60. And then you draw its apothem, splits that in part, giving you a 30, 60, 90-degree triangle. So this kind of quote unquote zoom in. So this is that triangle right now. This is that triangle right here. We got our apothem, making this 30, this 60, and of course the 90-degree angle. Now this is 4.5 all the way across. So since we split that in half, we split this in half, 2.25. Now, if we use our properties of 30, 60, 90, the 2.25 is our smaller side. So our apothem is the long leg. So to go from small to long leg, we multiply by radical 2, giving us an apothem of 2.25 radical 3. Perfect. So we got our apothem. Now we need our perimeter. Perimeter be just 4.5. So perimeter will just be our 4.5 times the number of sides we have. We have 6 sides, so times 6, you end up getting 27 right now. So we're 27 inches and 2.25 radical 3 inches. Now, as the formula goes, apothem times perimeter divided by 2. Let's do that. So we do apothem, 2.25 radical 3 times perimeter, 27 over 2. So if you have a calculator, you can literally plug it in like that. And that's what I'm going to do. I'm going to do 2.25 times, so second square root 3, make sure you error out, times 27. Get a number and then divide that by 2. Syntax error. One more time. So second, that'd be 2.25 radical 3 times 27, it's 105, and some decimal divided by 2, get 52.611. So we're going to keep a couple numbers for now. So this equals 52.611. All right. So I'm going to kind of give myself some space here. So we're going to go ahead and then cross multiply. Let's do that part to figure out what A is. So we're looking for X. So cross multiply right here, you end up getting 52.611 x squared equals, well, let's see what 4.5 square is. That gives you 20.25, and then times 41.6. So times, this gives us 20.25. We multiply it with 41.6. You get 842.4. Now again, we're looking for x squared, so divide both sides by the 52.611. 52.611. You get x squared to equal 16.0118 and a bunch of other numbers. So let's just square root that as it is. Second square root, second answer. When you square root that, you get x to equal roughly 4.001. We're going to round to the nearest one decimal. It's just be 4. So 4 inches. 4 inches is the length of this side right here. Now, the recipe says, hey, the recipe calls for a circular cake pan with a diameter 8. Which pan should we use? Well, we don't want to use one that's too big, because if it's too big, it keeps our cake very flat. But if we use it too small, it can make the cake to overfill. So we got to figure out, would it fit better in a 41 square inches pan or a 52? It's a big difference. So let's kind of figure that out. To figure that out, we need to find what the square footage or the square inches of this circular pan will be for this particular cake. So we'll do our pi radius square. Since the diameter is 8, we split that in half. We'll do pi times 4 square. So that gives us 16 pi. And let's take 16 times pi. Clear? Pi, that gives us, we're looking at, oh, syntax error, sorry, 16 pi 50.26. So that gives us roughly 50.27. So we should use the bigger one. So the bigger pan. This is too much for this pan right here. All right, y'all. Hopefully that helps you out some. I will see you tomorrow.